Hello everyone, today we're gonna start with something new which is called recurrence and using the answer the questions and require the transition the matrix. And also today we're gonna try to learn something is called state matrix. And yeah, hopefully you guys can understand after all. And yeah, let's getting started. So the type of problem is similar to those that considered by the financial modeling. So the recurrence relations and state matrix actually relate on the financial part. So if you want to do financial in your into the union or something, you're actually gonna using the recurrence and matrix and stuff. For example, if you had $3,000 invested at 5% per annually, um, and how much we'll have after 1 year or 2 years, 3 years. So this kind of question we're gonna use in with a recurrence. Um, so in the same way, we actually using recurrence relations to modeling the change the growth of the value in investment or law over time. So recurrence relations can be formed using the matrices, can modeling the change in the number of problem people's choosing to go to the movie or week by week. Starting point is examples like tell us how many people initially going to the movie, how many stay at home. So this from the last video, which is the examples with 200 people gonna go into the movie and 150 gonna stay at home, and it called the initial stay matrix. If you say S0, that means the stay initial. So S0 is means the initial state matrix. And to find the number of people who are going to the movie after 1 week and using transition matrix T. So transition matrix is representing T, and generate the next statement is S1. So I want you guys to write the write in your reference book is S1 equal to T times S0. So transition matrix we actually calculate by is 0.2, 0.4, 0.8, 0.6. So from the last video, if you want to have a look, please go through the last video as well. 200 and 150 and multiply by each other, and that will say how many for the next week. So which is after the week 1. And we actually predict the 100 people will go into the movie and 250 people are going to stay at home. Similar calculations, we're going to keep going with S2. So we're going to using the transition matrix times S1. So, and you just keep continue until the actually want to ask you the 3 weeks or 4 weeks. So in the end, we keep going and so on, 3 weeks, week 4, week 5, and then after that, we come up the formula, which is called Sn plus 1 equal to transition matrix times the before week or the before the n and Sn, so which is the state matrix, the before the next one. And the matrix, the recurrence, the relations, the generate the sequence, which is S0 is means initial matrix, state matrix, and then Sn plus 1 equal to T times Sn. I want you guys to write down this one in your reference book. Okay? So I'll give you guys ideas and what is the T means, what is S means, what Sn plus 1 means, and what S0 means. So let's start with some questions. Some people ask me actually, TSN, what does that mean? That means T times Sn, okay? So that's gonna be the same. Alright, same questions with the last video. Ferris wheels and merry-go-round, and then start with the 140 with the Ferris wheels, and 80 people gonna be the merry-go-round. And your transition matrix is T, so they're gonna ask you to predict number of children on the wheel and runs after one turn and after three turns. So we're gonna start with S1 equal to T times Sn0, sorry. So that equal to 0.8, 0.3, 0.2, 0.7 multiplied by 140 and 80. So that one, so we can use CAS calculator to calculate it. And I'm just doing maybe by hand, 0.8 times 140 plus 0.3 times 80 and 0.2 times 140 plus 0.7 times 80. So in the end, that equal to 136 and 4, I think 84. Yeah. Yep. So that's S1. So we're gonna calculate S3. So we're gonna calculate S2 first. So S2 equal to T and S1. Now I'm gonna use a CAS calculator because I'm not gonna doing by hand because it's too hard to do by hand. Well, you could try. If you can beat me, all right, then you got a reward during the class. So use the CAS calculator and then to calculate the matrix calculations, which is in the chapter 4b. Please go through the CAS calculator. And then turns out that equal to 134 and 86. That's the week 2. Because we're going to try to find the 3 turns, right? So which is we're going to find S3. So S3 equal to T S2, and that equal to same idea, 0.8, 0.3, 0.2, 0.7 times 134, 86, and that equal to 133 and 87. Okay. So it turns out you can say these all numbers adding all together in the end is equal to 220 people. So which is that's how that transition look like. Yeah. And that's called the statement matrix, right? Okay. Now I give you guys the time to try by yourself. And please use the CAS calculator, okay? So if you can't do by hand, use CAS calculator and find the 1 day or after 3 days. All right, let's move on to the next part. So now we're gonna try the explicit, the rules determine the statement after n applications of the recursion. So recursions, which is we can have a look with that. So first thing after n transitions, so you're gonna keep going in the transition, you can say, but to times the individuals, it's hard to actually just take a large time to do it. Do we have any choice like to do or can give us an easy way to recurrence relations, determine the matrix? We could start with initial statement. Next one, Tn plus 1, so Sn plus 1 equal to Tsn. And then explicit rule find the Sn is equal to the transition to the power of n and multiply by the initial state matrix. So that's the easiest way to do it. So you don't have to calculate how many times. So I want you guys to copy this one in your reference book again. So which is this way is a simple way. Way better than the before. Well, please copy the both. All right. So let's have a look at the question. So first thing first, let's try the question with the Ballarat of the movements of 2 cities, Geelong and the Ballarat movement, people between 2 cities. So there's 250,000 and 100,000 people. So which is Geelong have 250 G and B. Okay, so that's your initial statement. So once you read and they sometimes not give you the matrix, please write by yourself if you can't. Um, and the transition matrix can be used to chart the population movements between the two cities. So that's your transition matrix. Perfect. Now, first one. Using the recurrence rules, which is n plus 1 equals t. Okay, we're gonna find a 1 year, so which is s1 equal to t as 0, so that equal to 0 0.9, 0 0.15, 0 0.1, and 0 0.85, and times, so 250,000 and 100,000 people, and that equal to, so we're gonna use in CAS calculator, so we translate, and calculate it. Turns out that's equal to 241, 500,000 people. And there's 118,500 people. That's it. And then we're gonna translate to 3 and 4 years. So 2, 3, and 4 years populations. So, and this one we could using these rules again. So which is we can keep going with T2, S2, S3, S4, and I want you guys try to tell me the answer by yourself. Okay, so let me not have any questions. We're gonna using the same rules like that. So which is we're gonna go S2 equal to T S1, S3 equal to T S2. So we're gonna keep continue and until to the S4 equal to T S3. So I want you guys to calculate those rates and let me know the answer in the end after the after 4 years. Okay. Now we're gonna calculate another one. So C. We're gonna using the rule is Sn equal to T to the power n as 0 to find 20, 30, or 40 years. Now I'm gonna try with to find the Geelong's population. Okay, so which one is the Geelong's population? Translation chart, and we're gonna try to find Geelong's, which is top. So we're gonna use S20 equal to T to the power 20 and to the matrix, which is like 250,000, 100,000 people, and we're gonna try to find this one. So T20, so which is we're gonna try to do is 0 0.9, 0 0.15, 0 0.1, and 0 0.85 to the power 20, and 250,000 and 100,000. After that, we can find a Geelong person after 20 years is around like 260, so 216,000 people and 108. Well, I want you guys to figure out S4 is 30 and S40, okay? Use the same rule, so which is like S20 equal to T20 S0, okay? Like that. So what do you think 30 will be? What do you think the 40 will be? So we keep going with. And what do you notice about the Geelong? And what do you think that happened these like beyond 40 years? So this kind of question is like conclusions. So we could say in Geelong is declining, and from initials like 250,000 people to after 40 years, which is whatever you calculate is, and then but appears to the stabilize, which is around like some people's. And let me know what you think about the Geelong population, and then write down your thoughts. Okay, so that's the question D. What you guys want to do? All right. So after all, I want you guys to make sure you understand what's the recurrence, state matrix, and transition matrix looks like. Next video, we're gonna keep doing with applications of the matrix. So I want you guys to keep following. So that might be the last video for term one, and also the last video for the matrix. All right, see you guys next time.